Convolution or faltung theorem. Today we will have to study the statement, the meaning of convolution and faltung theorem. If ft and gt, these are two functions of class A, means these are sectionally continuous function and these functions are of exponential order. These two functions have these two properties. In this case, this function ft and gt will be called function of class A. Then the convolution of them is denoted and defined as f star g is equal to 0 to t fu g t minus u du. So if ft and gt be two functions of class A, that is, these functions are of exponential order, as well as these are sectionally continuous function, then the convolution of them is denoted and defined as f star g is equal to 0 to t fu gt minus u du. The relation f star g is also known as faltung or resultant of ft and gt. This convolution is commutative. It means if we change the order of these two functions, then results remains same. There will be no change in the result if we change the order of these two functions f and g. It means f star g is equal to g star f. That is, we can say 0 to t f u g t minus u du is equal to 0 to t gu f t minus u du. Because f star g is equal to g star f, therefore we substitute the values, and if we substitute the values, we will have 0 to t fu gt minus u du is equal to 0 to t gu ft minus u du. If inverse Laplace transform of fs is ft, that is, inverse Laplace transform of fs is ft and inverse Laplace transform of gs is gt, that is, inverse Laplace transform of gs is equal to gt. So let us assume if inverse Laplace transform of fs is ft and inverse Laplace transform of GS is GT, then inverse Laplace transform of Fs GS will be equal to 0 to t Fu gt minus u du, that is f star g. That is, if inverse Laplace transform of Fs is equal to Ft and inverse Laplace transform of Gs is Gt, then inverse Laplace transform of Fs Gs will be given by 0 to t Fu Gt minus u du, that is f star g. This is known as convolation or faltung theorem. So this is convolation or faltung theorem. So this is the statement or definition of convolation and faltung theorem. Thank you.